distributed deep learning inference at edge devices. So let us give our quick introduction that we are going to solve here. We know that deep neural network and the convolutional neural networks widely used and have many useful applications like computer vision. However, to execute this model, it is required to have significant amount of computational power, and also with this concept of smart things IoT devices are used everywhere for various tasks. However, these edge devices have main issue of having limited resources. So in the other hand, we have really useful convolutional neural network which is computationally expensive, and in the other side we have widely used resource constraints devices like Raspberry Pi devices. So how we can use them together? That's the issue we are trying to solve here. So what is our motivation behind this? When we are doing various kind of computer vision related projects in resource constrained devices like Raspberry Pi, inference time is always really high if the convolutional neural network is considerably large. So as a solution, we are more focused on improving the inference time of the convolutional neural network on edge devices like Raspberry Pi. Also, handling convolutional neural network on IoT device has many real-world applications, like on security camera system without a server, or a mobile camera system which can be detect human. So we identified there are really little amount of research in this area, and by doing the computation on edge device without a cloud-based solution, we can ensure the privacy of data and low latency. We built a Raspberry Pi cluster for this project. At the time we were recording this video, all the devices are at the ideal state. Here we have 4-port router which is used as a communication hub for all 4 Raspberry Pi devices. These green lights are indicating that each Raspberry Pi is successfully connected to the router. So let's have a basic idea on what is happening here. Let's assume we are having an image with size 9 by 9 has to be distributed with 3 devices. So the overlapping is as shown. So now the convolution happens separately in each devices. As shown, we need to remove the garbage rows before sending them to main device. Again, the communication happens to the hub. After receiving all data, main device combine them and complete the convolution task. Especially remember that in real classification model or object detection model, there are a lot of restrictions to handle. Then let's compare the result with trained model for 5 classes which gave the validation accuracy around 87%. Here, all the 4 videos going simultaneously for same input set of images. Also, we print in the accuracy percentage, inference time and classification classes. So the inference with 4 device finished the task early, then inference with 3 device and 2 device finished the task accordingly. As you can see here, inference with 1 device is still going or still doing the task. This result may vary according to the model architecture. So this is our one of major evaluation which is based on VGG16 model. In here, we got nearly 30% of speed up in Ethernet communication and nearly 23% of speed up in Wi-Fi connection. So that's all. Thank you.